Okay. Am I audible? Yeah, I think so. So, I believe that everyone has already faced an issue about the performance in the production. And most probably they got this issue whenever they want to believe that their product is kind of good shape, but they got this one. So if you ask me, I got these kind of issues. That's fine. There is a continuous performance testing. And I'll talk about how we can automate the performance testing in CI pipeline, and from data, how we can evaluate the results without human interaction. So let's give me an idea about myself. So my name is Mesut. I'm based in Turkey. And I'm working as a principal consultant at Modus Create. And you can find me in the internet with this info and QR code. So you can connect me with within the LinkedIn. Let me get an idea about the audience. Do we have any developers here? Can you raise your hand? Do we have any developers? Yeah, good. And also, do we have any QAs? Most probably we have a lot of. Yes. So specifically, does anyone do performance testing and title performance engineer? This is kind of tough question, but yeah, I see. Good. And I believe that everyone has already contributed in performance testing project. Did anyone do performance testing before? Okay, good. So the subject is from data to insight and continuous performance testing. This is the table of content. So I will talk about what is continuous performance testing, and then how we can do the continuous performance testing in the pipeline. And there's a problem about the evaluation and how we can do this evaluation with the machine learning model. And there will be also demo, and then you can understand what I'm talking about, continuous performance testing and evaluation. So let's start with the continuous performance testing, or CPT. So you can see that continuous performance testing is in the pipeline as a task for testing the performance side of the product. So it is running continuously, which means that whenever there is a change on the code base, and you will get an idea about the performance about the system. So whenever there is a problem regarding the performance of the system, then there should be an alert that you don't go beyond. I mean, deploy it to the maybe production, maybe the code base, and analyze it. Basically, whenever we talk about the test pyramid, we are mostly talking about two dimensions. The first one is the test level and the test type. But there is also maybe the third dimension, which is for the non-functional thing. And you can see that in red, we can apply the different type of performance testing for the continuous performance as part of our CI pipeline. And the strategy, so you see that we can apply the performance testing for different level, which means that it can be on the maybe unit level, maybe integration level, maybe as a system level. So you can see an image that different type of performance testing can be applied. This is the integration level, the first one, but as a system under test, as a production, that you can also test that one. Also, you can do the both to get maximum benefits. And the strategy means that where we apply the performance testing in our pipeline. So, and which kind of performance testing type should be applied. So basically, this is not the subject on the continuous performance testing, but I need to define it here. There are lots of different performance testing type, but the best one for the continuous performance testing is applying the automated load testing. Because load testing is is we are always expecting the same results with the same load. So which means that it can be repeatable and it can be automated. Other types are hard to simulate and hard to evaluate. So the best candidate for the continuous performance testing is applying the load test. Let's talk about the second part, collecting data. One of the problem with our whole system is collecting data and evaluating data. So data is very important because depends on the data, we will do some analysis. If the data is not correct or not in a correct shape or not in a correct format, or let's say not in a normalized way, normalized data, then we cannot do the good analysis and evaluation, and we cannot create a good machine learning model. So data should be enough, but not too much. And this is one of the ways that we can collect the data processing, or let's say. So in our system, we should run the test and then record the data in a different format, but in my case, it is a CSV format, and evaluate the result of the data. If it is satisfied, then we can get in a good shape that we want to store in our database or some hardware. So then update the historical data. And the evaluation problem. This is one of the core subjects in my talk. Actually, we can say the test is passed or failed. That is the easy thing. For example, if there is an unexpected error, then it is failed, obviously. But if there is no failure, but the result is satisfied or not, this is the problem of the evaluation. So the change can be important because we should catch the different type of issues from the data if we do a good analysis on our data, and if the machine learning model is behaving that your system is in a good shape or not. And one way, and the easiest way, maybe we can use a threshold as a static evaluation. So this is a screenshot from the K6. K6 is one of the open source performance testing tooling. And the data is static, which means that I'm saying that the average should be less than 20 milliseconds, and the P90 should be less than 30 seconds, and so on. So I'm also using that there should be 1,000 virtual users, and it should test 30 seconds. This is the easy way. And with this way, we can evaluate the system. But it is not a smart way, right? It is just static, and our system might be changed. And the next one is using statistical methods, using the normal distribution, which means that your historical data is comparable with the current test results, which means that if your current test result is within the acceptable range, then we can say that this is passing, and we can apply this one for every metrics that we have in the system from the performance testing toolings. And the third one, I think this is the critical one, using AI and ML for evaluating the results. So basically, we can use the machine learning to use data, analyze data, and then also create a machine learning model to check the results with the current one. So basically, machine learning is a subset of artificial intelligence, and it is creating a formula to analyze your data from your data. And with this way, we can identify any problem that is in your current results. And machine learning model, machine learning is evaluating, using the machine learning for evaluation is also done in a process. So basically, what we need to do is just we need to collect the data, and we should have some historical data. So after we have the historical data and the current data, we have to process the data that can be comparable and applied to the machine learning model. And after that, we choose a best model for our system. When we get the best model, then we have to train the model with the historical data. And then we can evaluate the result with the current result. So you can imagine that there is a historical data with maybe thousands of records, and there is one other record. There is only just one record, and then we just compare with these two data. And also, evaluation is not that simple, because we have to consider a lot of stuff. And then because of this one, we have to go beyond your data and understand your data, your behavior. Sometimes there might be some outliers, and it can break your system as a machine learning model. So machine learning model should understand this kind of data, and then it should be extracting this kind of data. And the machine learning model should be training. For training the model, we can use the historical data. So let's say the 80% of the historical data can be used for training the data, and 20% of the data should be test the data. And at the end of the process, we should also evaluate the result, if it is satisfied or not. If it is not that, then we should train it again, and then check the results. If it is, okay, satisfying, then we can continue with that. So basically, in the machine learning evaluation, we have three kinds of evaluation. The first one is anomaly detection, or let's say checking if there is any outliers in your data. So with this one, we are using some anomaly detection machine learning methods. So which means that we have we get the historical data, and then get an average for each data, and then we are putting some thresholds, just training with the data. So which means that there is an average, there is an upper boundary, and there is a lower boundary with each matrix. So you can see from the image, it starts from the minimum value, then median, and also average and P9. So it goes up, because we are expecting that minimum should be always minimum. And in the yellow one, it is the data that we get currently, so the last test results. If it is something above or below or for this graph, then we are saying that it is something outlier in the system, and there is an anomaly in our system. So this is the first one, and the second one is checking the regression. Regression means that there is a data, and there is also new data. With the historical data and the current data, we should be observing that it is always the new data is really belong to the historical data. So for this one, we are using random forest as a machine learning model to get the results. So basically, there are independent variables and dependent variables. So the independent variables can be every matrix in the performance testing result. It can be mean, average, median, or whatever. But the dependent variable is the variable that we are testing. So for example, if we are testing the mean value, then all others should be the independent variable. Based on this one, we can create a formula to check if our dependent variable is really in this range. And the third evaluation is checking the trend. You can imagine that your test result is okay, but there is an inclining inclining results. I mean, it always goes up, but you cannot imagine, you cannot understand it by eyes. So if you check the results with historical data, then you can see that if there is a trend or not. So this is also checking checking if there's a trend or not. This is a graph that's showing the upper and the lower boundary again, and then checking the current result if it is within the confidence level. And if it is in the confidence level, then it says that there is no trend in our test result with the historical data. And let's go with the demo. Okay. For demo purpose, I create a simple app, which is called Dog app. You can also access this project. It's a public project from my GitHub account, and it is a Dog app. Basically, this app is a microservice-based has a microservice-based architecture, and it has only 4 different microservices. For the demo purposes, we will test the dog register, which is registering the dog. And with this one, I created a merge request. And for this merge request, within every commit that we push to remote repository, then it will trigger an test. It tests everything. I mean, starting from unit test, also contract testing, and the subject is the performance testing. It also do the performance testing. And after performance testing is done, it starts with the evaluation. There are three types of evaluation. The first one is anomaly detection, as I said. And second one, regression analysis. And the third one is the trend analysis. So for this commit, it is passing. How much time? Okay, I have 7 minutes. So as I said, this is the historical data. So we have a lot of data, and it should be good enough. I mean, not much, not less. And on the left side, it is the historical data, and on the right side, it is the test result for the latest test run. So basically, we have 3 modules to test the different aspects of the performance testing results. So the first one is testing the anomaly. So you can see that it is reading the historical data, and then also it is reading the current data. And also there is a scaler. With the scaler, we are just normalize the data. After that, we are just doing a training. And after the training, then we are just checking the result is okay. If the result is okay, then we are just asserting that all the results should be anomaly false. Samely, we have also regression. We are also doing the same thing, just loading historical data and then current data. And after that, we do the evaluation. After training, we do the evaluation and checking that all the results should be satisfying. Samely for the trend analysis, we are also loading current and historical data and just doing the evaluation for them and checking all results are satisfied. And let's do the demo part. So I just do a commit and start a push. After, when I commit to changes, then there is a trigger on the PR, and it starts checking the results. So you see that unit test is just started. I'm just streaming, and don't wait until it gets. So this is the performance testing. With the performance testing, we are just installing the K6, and then K6 starts to hit the service. When it is finished, then the evaluation task starts. When the evaluation starts, we see that it installs some Python packages, and then do the evaluation. Yeah, when all the evaluation is okay, yeah. So there is another task that collecting data and updating the historical data. So you see that deploy task is green because all tests passed, and just we want to deploy the last commit to the production, whatever. So we can see the results. This is one of the results, checking the matrix. So you see that it creates a lot of data, but everyone is clear. So you can see in the green area that it is the acceptable range, which means that if the current result is in this range, then it is okay. So just going faster because I have very limited time. So I just added, you can see that I just added 0.2 milliseconds as a delay for registering a dog, and then I just want to get the results. So it is very minimal, but it caused a problem on the system because all the metrics are very small. Just again running the test. This is one test, and this is installing the K6. And when the test is okay, then it starts evaluation and checking the results. And yeah, so tests are failed. Yeah, just 2 minutes left. So you can see that deploy is failed. I mean, it was not run because tests were failed. But collecting data and updating the data worked because it should be. And this is the result. You can see that the average is as an outlier because we added some delay. But it was very minimal. I mean, 0.2 milliseconds, but it failed. But P90% is not failed. Similarly, P95 failed. And this is a regression analysis. Some of the metrics are still okay, but some of them not okay. And this is a trend analysis. You see that some of the trend analysis is okay, but some of them are not. Yeah, so basically, this is the demo. And so we will get a lot of benefits from the continuous performance testing. One of them is just getting the quick feedback about the system. Whenever there is a change, we will get that system is okay in terms of performance or not. Also, this creates an awareness for the team that if I create something on or some functionality that has some side effect on the performance side, then I should be aware that it can be cached, and I should be develop it in terms of performance testing sake. So thank you. That's all from my side. You can download the presentation, and also there are some reference for my work. And also you can check the GitHub code. It is public. And yeah, if you have any question, I can answer. Thank you. There is one question here.
My question is about continuous part of the performance testing. Actually, this is an easy, basic question. When we say continuous performance testing, it is sometimes understood that we run performance testing each time on the pipeline for each kind of chains. If this is not the case, do we have a selection criteria for running performance tests?
Yeah, ideally we should run the performance testing for each commit. But when you say with the selection, maybe there is a thing that my code doesn't anything that affect the performance testing, then I can skip it. But for ideally, I think every commit should be tested in terms of performance testing in whatever level you want. It can be unit, it can be integration, or it can be in a system level. So we can get the benefits,
Okay.
whatever you want to go with the strategy.
I am asking because performance testing is something expensive.
Yeah.
It is not easy to provide data, environment, configuration,
Yeah.
and scaling issues. So,
Absolutely.
As you said, there must be
Yeah,
some
absolutely. It is
criteria to
expensive.
select.
It is expensive. That's why I just want to mention the automated load test. Automated load test is the basic form of the performance testing. So there is always defined load levels, and there is always defined expected response. So I mean, you can maybe use the CI server as part of the performance testing, or maybe dedicated server is the best one, then to get the best benefits from that. So it is expensive, but having a problem on the production, I think, more expensive.
Thank you.
Any question? Yeah, I think that's it. Thank you.